Hi! This video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Coders, good morning. Or good afternoon. It's morning as I record this. We are about to do step 22, which is a high score table. The last time we added a title screen, but it was empty, and now we have a title screen in this step. And it works halfway, meaning that it is preloaded with a number of scores, all with the same name. And if we break the high score, or if we break into the high score table, our score is entered at the right spot in the table. Let's just first see at what this looks like. Well, it looks like this. And I'll demonstrate a little bit. I'll press fire to play, and I'm going to aim for having 150 points so that we can see that it works on that line. So we fire, wait, fire, 30 points, fire, 100 points. I get extra ammo. Oh, I've got 130 now. Oh, which is good, which is what we wanted. Now I have to die. I'll just die touching the various enemies here. Okay. And now we can see our score is the 300 one, and it's come between 1000 and 130, and the 100 has disappeared. And also the border colors changed, but that has more to do with the fact that one of the parameters is equal to the score number, and that number is set to the border color, which is 7 in this case, which makes the border yellow. Okay. Now, let's have a look at the code, because there's some other minor changes that I'd like to talk about as well. The first thing that I noticed, and that is something that as a programmer you are bound to run into, and you have to make a choice very early on when you first start your first program. You have to choose whether you are going to use labels, or for register numbers you're going to use their hexadecimal representation or their decimal. Now, we started out with labels, like we had a whole bunch of Vic labels. I can't show them now because they've been removed. This means that in every case where we addressed a register, we were able to use the label name, but now our friendly programmer has moved to this. So he's using he's decided not to use the labels anymore. Now, there's something to say for that, because if you only use the labels, you will never get a feel for the actual register numbers, right? So, but then there's the choice. Because you're always looking at the labels, you're always looking at a Vic scroll or Vic raster or whatever, and you never know which number that is because you never see it. Now, this editor was helping. I prefer the labels, and this editor was helping me because I could hover over the number, over the label, and it would give me both the hexadecimal and decimal representation of that register number. Now, in this version of the code, we have the decimal numbers. Now, when you go the decimal way or the hexadecimal, but this, what you see here, is usually done in decimal mode. This is a technique that I mostly see in BASIC, that you use the base address of the SID chip or the VIC chip, whatever you are using, and then add a number. This is what they do in the Commodore manual. Right? This was like the intended or the proposed way to do it. Now, this has never been my preference. So I'm kind of sad that this is now the way that we're going. Luckily, there aren't that many places in the code at the moment where these registers are being used, but I'm never going to remember this number for some reason. If I prefer the hex representation of this to the decimal representation, and the editor doesn't help me with a tooltip saying, oh, this is hex that. So now I'm gonna have to use a calculator to see, oh, which register number is that. So a number of the changes in the code have to do with this. It doesn't change anything in the functionalities, just a preference for how are you going to work. And the preference in this case is this, which isn't my personal one, but you know, you got to live with what you're given, and maybe it'll change in the future. I don't know, but sprite colors, because background. Oh, okay. So the background is a fixed one, and then multicolor is that. Oh, the multicolor character set. We use the fixed number again, and here we go. I have no idea. If I see this, I have no idea which register we're talking about. Maybe if I ran a calculator, 53248, 53248 in hex. Oh, that's D000. Okay, so this is DO16, DO21, and DO28. So okay, you know, that's no. See, that's 16. If I type this plus 16, that is DO10. See, there we go. I was thinking 16, but no. Okay, so that's a change. Okay, no judgment. Let's just continue. So everywhere where there was a label explaining what the register did, now we have to deal with this. Not that many places, so it's not such a bad thing, I suppose. Let's have a look at what this change is really about. It is this. I scrolled to the bottom, had a look at the data, and this is what we find. Now, there's high score names. This is just for display purposes at this moment. This is what we're going to change. So if anything changes, you can't enter your name yet, so it's all supernatural, and we have to find a way of determining whether our score at the end of our game fits anywhere in this list. So we have to start comparing these numbers, and then when we find the place where our score goes, we have to shift everything. So our score was 130, so that was supposed to go in the bottom. Was it 130? Yeah, it was 130. It's supposed to go in the bottom row, and this row has to disappear. If our score had been higher, so if we had scored 350, then our score would have come at this place, this location, and the 300 would have had to shift down as, the 100 would have disappeared. That's the functionality. Don't be fooled by this representation, because we're really looking at a string, and at the end of this string is a hyphen, which is interpreted as a next line. So the display routine takes this and makes it, but this is actually here in the string, so we have to take that into account. The asterisk means the end of the string, so this is where the display routine stops displaying. This is one of those cases where you decide at the start that you're going to go a certain way, and at a certain point you're going to be confronted with your choice. You chose a certain way, and now you think, "Ooh, now I have to solve this problem in a certain way because of my choice." The choice that I'm talking about, of course, is that the score, and I'll scroll up a little bit, our score is held in memory just like this. There's no variable, there's no memory location other than this one that holds our score. So it's just a couple of numbers on the screen. Now, in any other programming language, you would have this stuff in an array, and you would sort the array, and you would determine which location your score goes, and you would, it's a lot easier, but partly because your data structures are more advanced. In assembly, we have no data structures to speak of, so all we have is a string of numbers, and we know that each high score entry has 9 digits, right? 8 digits for the score, and I'm calling this a digit, but it's 9 characters wide. And that we have 1, 2, 3, 4, 5, 6, 7, 8 entries. That's it. There's some constants that will help us. I'm scrolling way to the top. Whoop! There we are. And this is them. There's a high score entry count, so there are 8 entries. There is a high score size, which is 8 digits. We shouldn't forget the hyphen, which makes it 9, but we'll get back to that later. The high score name size is 12, but we don't do anything with that yet. So I can scroll through the source code, which I will do, and I will show you the interesting bits, because there we go, 235, going down to line 235, not too fast. Yeah, we have to display the high score. So this section of the code is the title screen game loop, right? So we've done our primary setup, and then the title screen starts with the whole button pressed and button released thing, which we talked about in the previous one, but now we've just added the high score table to it. So X and Y position, we load the high score name table, and we print them, and then the scores come along. We point the 0 page pointer at the high score, and that goes into display text, and that's done, right? That shows the power of our display text function. We can just set it up, call it, and it works. We don't have to think about it anymore. But then we also have to make sure. Oh, that's it. Okay, right. There's a new function called check for high score, which is up next at 433. Scrolling down. So this is the function that we're going to talk about in this episode, the check for high score code. And I'll walk you through it. There's a couple of things that you have to know, and but we have to understand what happens. This is some nice data wrangling, and it's a nice depiction of the work that you have to do as an assembly language programmer, especially when you're programming games, because hey, a high score table is gaming, right? But this function is called somewhere as well, and that is 559. I'll go down that 599. Where is it called? 599. Oh, 559. Sorry, 559. There it is. So that's on a restart if the last life is an F. If last life return to title. So this is the same place where we were before. Oh, we jumped to the title screen before. That's what we did. Oh, that's nice. So instead of jumping straight to the title screen, we jump to check for high score, and that jumps to title screen. So, and title screen is like the title screen loop, right? That's just the beginning. It clears the screen and it sets the colors and blah, blah, blah. That's what we just looked at before. So we're ready to start looking at the big one, the 433. There we go. Check for high score. Now I'm just going to go through this, and I'm going to give myself a little bit of extra room here. Boop. Oh, I'm going to get that out of here and get that out of here. So this and like that. Right. So what do? We have a parameter. We have no incoming parameters, so we just destroy everything. No, let's rewind that. We have no incoming parameters. We use parameter 1, we set that to 0, and we set y to 0, we set x to 0, and we store y in parameter 2. Now, we don't know what those are yet, but as we can see, we load something from the screen plus that indexed by x. This is our score. This is our current score. And we look at the start of our score. X is 0, so that's the index into this memory location. So we're going through the score from left to right. So this is our 130 points that we scored. And we're looking at the first 0 of that score, right? Then we're comparing that to high score. That is the high score table. I've made a little visual aid, if you will. I can't really get it into, but if you look at it this way, this screen character blah 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 plus x, that is our score. In this example I used 150, but I know it's 130. The effect is the same. And so our x is indexing this piece of memory, and then high score, that is this table. So that's just a list of scores with the minuses and everything. And I've made an alternate representation, but it's the same thing. So that's just the scores. We have 8 of them going from top to bottom, and there's 9 characters in each line, right? That's the way it goes. Now, I'm just going to leave this in for now. What the compare does really is that it subtracts the value that it finds here. So a high score, it points at this location, right, at the top. So what it does is it loads the character value of this 0, and it compares it with the character value that is sitting here. And comparison means that this value is subtracted from the value in the accumulator, which is that value, and the result is 0. Now, I knew that we were going to have to look at how the carry works pretty quickly, but there's another thing. The Commodore 64 has a chip, the CPU. It has a binary coded decimal mode, which basically means that it counts and nibbles, half bytes count from 0 to 9, and then not to A or 10. They just go to 0 again. So that was meant to aid business applications, so that you could do decimal math easier. This mode is often used, I would imagine, in handling this kind of thing. We're doing decimal math here, but we're not using that in this case. So that's just as an aside. But we have to realize what we're doing, I think, because the value that we're loading off the screen is not 0, but it's, and I'm typing it in here, it's 30. 30 is the Petsky code for the character 0, right? And 39. I mean, it's chosen wisely, of course, and 39, and it just goes up like that. 31, 32, blah blah blah. So these are actually the values that we're comparing. You could do this in binary, and it would look different, but we might as well just do it this way. I mean, there's really no difference. So, okay, we've had that, right? Just know that we're doing that. It plays no other part. Now, there's another lesson here about the carry. The carry bit is a part of the processor status register, and it holds the carry. Now, the Commodore cannot do addition or subtraction without using the carry. This means add with carry, and this means subtract with carry. Add with carry means that whenever you use the add with carry command, the carry value is always added. So if I made an example for add with carry, if I did this, right, if I loaded A with 0 and I set the carry bit, and I did this, I added 0, you might think that the result of this would be that the accumulator equals 0, but that's not right, because we set the carry, and add with carry adds the carry as well. So it does this, and the carry was 1 because we set it, so the result is 1, right? That's how the carry works. You don't see it, but it's definitely there. So you always add with carry. That's why when you see additions, you see usually clear the carry, which will make the result 0. Now, we're looking at comparison here, and comparison is subtraction. So when you do subtraction, we set the carry SBC, because the carry works exactly the other way around. When you do a subtraction and the result is let's see how this works. If I did this, then what it would basically do is 0 minus, I can't see my keyboard, so I have to minus 5, that would, of course, wrap around. So I don't know what the number is, but it's at 255 minus 5, so it'll be 250 or 251 or something. And the result would be that the carry is cleared because it is used. You know, we're doing a subtraction, which will result in like an overflow, and the carry is actually used, and the carry is set to 0 at the end. So we can use the carry to see what happens. If it was the other way around, if it was 5 and we subtracted 1, we still have to set the carry. So what happens now is 5 minus 1, which equals 4, and the carry is still set after this. Right? So we get a little feel for what happens. So if 0 minus 5 is 251, I'm not sure if that's correct, but the carry is cleared. In this case, the carry is still set because it wasn't used, right? We set the carry to 1 before the subtraction. In this case, we needed the carry, so afterwards the carry was cleared. In this case, the carry is still set because nothing happened to it. If this happened, there's one other case, and the result was 0, the carry is still set because it wasn't used, right? So only if the sign of the result changes, was a carry needed, and is the carry cleared. So that is the only case in which we know with one test, okay, so the first value was smaller than the second value. So to recap, when we add, the carry is cleared and used during the addition. When subtracting, we have to set the carry, and it works in exactly the other way around. We can test afterwards what happened in the subtraction. So that's a little bit of a carry lesson. We're going to look at how we use that here, because we subtract the... Oh, there goes our example because I clicked. We subtract the high score from the actual score that we got. Now the result, we're still looking at this 0, and we're looking at this 0, and they are equal. So the carry wasn't used. So after that, the carry was set, right? Because the carry wasn't used. So now we have to check whether they were equal, and they were, because they were both 30. So we can check branch equal or not equal. Now branch not equal goes to is higher. So we go to check the next digit. So what this code does, it increases y, increases x. It checks whether we are at the end of the high score size. Get it back. High score size means like the end of the string. At the end of the row. If it is, then our score is higher and we can jump out. Otherwise, we just check the next digit. So this piece of code runs through each number and says, "Hey, how's our score doing as opposed to the high score on this line?" Yeah, you still with me? So that's the technique. Apparently, we're going to take our score and we're going to check it against this line. If we run into a number that says, "Hey, this says 5," where this says 0, then what's going to happen is that we're going to subtract 5 from 0. That's going to set the carry, right? No, sorry. The carry was set. That's going to clear the carry because it's going to use a carry. So branch on carry clear means, hey, the high score is definitely higher than our score. So we jump to the not higher one. Now, this increases parameter 1. We load parameter 1 and we check it against the entry count. So parameter 1, which started at 0, points at the row that we're looking at. So we increase the row. We basically just go to the next row. So we compare against the entry count. If it's 0, then we have no new high score. So that means that if we run through the table and we are at the last line, then there wasn't any new high score, and we can just end. But we still have work to do. Let me take a sip of water. Okay, so we go to the next line. Now y was still pointing at the 5 where we got triggered to go to the next line. So we load the value of parameter 2, which was 0 at the start. We clear the carry. We know that why that is now. We add the high score size, which is 8, plus 1, which is 9. So we started at 0. We add 8 plus 1, and we end up here. We end up pointing at the first character of the next score. We transfer that back to y, and we do check score entry, which is here. And y is stored in parameter 2. So parameter 2 points to the current line where we are working. Now this goes on, so it checks this score against our score, and the same thing happens here. The same thing happens, and the same thing happens, and the same thing happens. The same thing happens until we are here. Now, what will happen here is that we run into a 1, and a 1 is compared to a 1, so the carry is still set, so we have to keep checking. Branch not equal, well, they are equal, so we have to check the next digit. So we come up here. We load 5 here. We compare that against a 0 here. So this time we do 5 minus 0. The branch is still set. The branch. The carry is still set. Am I right? 5 minus 0. Yeah, the carry is still set. Branch on carry clear. No. I don't think so. Branch not equal. Right, they're not equal. Right? Because we did 5 minus 1. It's not 0. So it is higher. So So we go to is higher. So we've determined now that our score is now higher, right? So is higher, and this is where we start with the whole shifting operation, because now we've found this is the first time that after checking a location that is equal, so we've actually this is the first time checking all these numbers that we've come to this call, right? If after subtraction we've determined, hey, our score is higher than the high score, and the numbers aren't equal, that must mean that we are higher, right? We're better now. So, and we know the location. We are better than the location that we're in, and we do that for any digit that we see in this line until we hit the end, because if we hit the high score size, then we're also higher. So even if we're even if we're equal, so even if we scored 100 points, we would take this place, right? That's what this says. So let's have a look at what happens when you have to shift everything. Parameter 1, oh God. Parameter 1 is pointing at this line. The value is 7. The color that it gives is yellow. We've seen that. I'm gonna have to shift this a little bit to the right to see what we have. We can do that. Just room enough. So we set the high score entry count, which was 8. We subtract 1, it says 7. So that is pointing at this row then, at the last row. Y carries the offset into the score, which is correct because we ended up here somewhere, but we have to recalculate. Y is going to be, this is a constant, by the way, right? There's nothing variable in this because these are constants as well. So the high score size plus 1, which is 9, times the high score entry count, which was 8 minus 2 is 6. So that's 9 times 6. I've already worked this out. It comes down to this position, and I wrote that down here. Now, parameter 2 was still pointing at the place where we were going to. No, parameter 1 was pointing at the place where we were going to put our code. So this is a special situation where both these values are the same, but you can imagine that if we were pointing at this one, that everything below would have to scroll down. Now let's look at this copy score function part of the code. We load parameter 2, we compare it to parameter 1. If they're equal, then we can set new score. Well, in this case, that is the case, so we can immediately look at what happens. Y points at score above the new entry, which is true. Y goes to A, we clear the carry, we add a whole and that goes to Y again. Okay, right. Y is pointing here, and it's pointing above. So we add one thing, so Y points to this. And what do? We just, X is 0, we load our score, and we store it in the high score plus Y, which is this location, increase X, increase Y, and we compare it to the size, and then, so this is just a loop that copies all of the digits from the score into that location. Now, what if parameter 1 and parameter 2 weren't equal? Right, so branch equals 0, then set new score. Otherwise, what we do is we're going to copy the scores. So Y points at the location above where we have to go. So we load that. We store it to the location below it. Increase Y, increase X. If we're at the end of the size, we compare with the end of the size. If we're not equal, then we do that. So we copy the current score to the next line. Y goes to A. We subtract high score size. Okay. So we go up one line. A goes to Y, and we decrease parameter 2. Oh. And parameter 2 was, it's jump to copy score. Right. So I'm gonna have to. It's kind of. I mean, this is where syntax gets the better of me. Parameter 1 doesn't mean anything. Was parameter 1 the one? Parameter 1 was. If we had a new high score, is higher. Parameter 1, this checks the digits. Increase parameter 1. Right, parameter 1 was if parameters say that our score was 1300. Yeah, we would. So in that case, parameter 1 would point here. Right? And we're gonna forget about this. We're gonna forget about this for now. So this is the situation. We've determined that our score, which is 1300, I'll change it. 1300. And it goes there. Because below that one, it's over that one, and these three all have to go down. So is higher. That's where we jump. Is higher. There we go. Now, the color is 5, so that's correct. High score, and okay, so parameter 2 always points to the last one, apparently. I'm just gonna, we could debug this. I'm just gonna do it by hand, so that we know what's up. High score entry count. So parameter 2 always points at that. Y points at high score size. Okay, so this is always the same. Y always points at this one. Right, high score size 9 times 6 is 54. It's always that location. So we have Y pointing. I mean, parameter 1 and parameter 2 are the line numbers, and Y is basically a per digit index. So we compare parameter 2 and parameter 1. They are not the same. So we go into this code, X is 0. So we copy this one. Yeah, but if Y always points here, then we always start there, which would be odd, wouldn't it? Oh, maybe it wouldn't be. Maybe it wouldn't be. Oh, we go up. We go up. That's what we do. That's what we do. So it doesn't matter where parameter 1 is. You set Y. You just always start at this line. And you copy. The first thing that this code does is it always, I mean, if any line is added, the last one is always going to suffer, right? It's always going to fall off, even if it's 100. But, so this will be copied to the line below. This is what happens here. Increase X and Y, check for the end of and then copy the next. So after that's done, Y goes to A, we subtract high score size plus high score size plus 1. So that's just one line, I would imagine. Because Y is gone here, I think. So high score size, that's plus, and then high score size plus 1. So it'll point at that one. And then it decrease parameter 2, which will then be pointing there. Oh, wait a minute. Y goes to A, and then A goes to Y. It's pointing there, but Y has gone up, so we're pointing. I think we're pointing Y there. Decrease parameter 2, which was pointing at the last one. Copy score, and then we compare them, and if they're equal, so that's what's happening, right? So Y is just used to copy the score, and parameter 2 is used to indicate where we are, and as soon as they are the same, we know that we can start copying the score there. So we're just cleaning up, and we're starting at the next to last one. We're moving that down, and when we're the same, we can copy our score in there, and that's it. Yeah. And that's it, because set new score, and after set new score, we've just gone through this, and then it's jumped to title screen. So, whew. So that is how the high score screen works. This would have had me thinking for a long time. I mean, I'm impressed. This is one of those things, I find this very, I mean, if you look at this code, you know, you can work out how it works, but what I've been able to write this, I mean, this does exactly what you need, but it is hard. It is hard to get it right. This is not the type of code that I would sit down and just write in one go, right? It is quite complex, but once you have to start with this, you know, you have to start by drawing this out and having pointers and thinking, you know, first I'm going to have to work out where to start, and then I'm going to have to start shifting stuff down until this is that, and once you have that plan, you can start coding. But it's a tricky one, but it works, and that's what counts in the end. I found this a difficult one. There's nothing in Georg's description about how he felt this was hard. I would love for him to tell us, you know, to say, yeah, I had a little trouble with this one because it's quite complex, or it had me going for a while, or maybe said, well, you know, I just sat down and write it. In that case, Georg is a better programmer than I am, because I thought this was a challenge. Okay, but we've worked through it. I know how it works, and this will be the type of code that I copy and paste the next time that I need it, probably. So that is it for now, and yeah, I'll guess I'll see you in the next one. Thanks for watching. Thanks for commenting, and bye bye.